In this video, we're going to be solving Leetcode question 61, which is rotate list. Let's get started. In this question, we are given a linked list that's going to look something like this. And we are also given a number k, and this represents the number of nodes in which we want to rotate the list. So if we rotate the list by 1, it's going to look like this. Basically, the first 4 elements are going to be pushed over here, and the last element is going to become the first element of the list. If we rotate by 2, well, now the last 2 elements are going to be pushed to the first 2 elements of the list. So when I first saw this problem, I initially viewed the linked list like a straight line. So in this case, it would be like a straight line going from 1 to 5. And then to rotate the linked list by 2, what we really want to do is find the last 2 elements of the linked list. In this case, it would be 4 and 5. We want to remove them from the end of the linked list, like this. And this would also mean making sure the next last pointer, so with 3, points to empty space. And then we want to move those two nodes to the start of the list. 4 points to 5. And then 5 would have to point to the head of the initial list, which is 1. This is a fine way to look at it. The first thing we would need to do is go through the linked list once to actually get a count of how many nodes are in the linked list. Because then only we know how many nodes we have to remove from the end of the linked list. So we go through the linked list once and we count that there are 5 nodes. And we see that we want to rotate by 2. So that means we want to keep the first 5 minus 2 or 3 nodes. So 5 minus 2 equals 3. So the first 3 nodes need to be kept in the current order they are. The remaining nodes after that need to be removed and then placed at the beginning of the list as opposed to the end of the list. So we go through that. We go through 3 nodes in the list. That's 1, 2, 3. And then we start removing here. We have to keep these nodes in some sort of set so we don't forget their values. So we're going to have a set here that contains the node 4 because we just saw that. And we're going to remove it and then go to the next node 5. 5 we also are going to save right here. Right, and then clean that all up. Now we're just left with this. And now we got to go back to our set and then move the nodes back to the beginning of the list. So 4 would go here. So erase this and then put 4 where it's supposed to be at the start. And then we would have to take 5, take 5, and then put 5 right after 4. And then once we're out of nodes in the set, we want to connect the last node we found to the first node in the original list, which is 1. So that's how you would do it in sort of a linear fashion. But here is how a simple change in perspective can make a problem significantly easier. So like I said, originally I viewed the problem as a linear linked list that goes from like left to right, for instance. But what if instead we imagine we wrap the nodes around each other to make almost like a circle-like shape? So 1 starts here, then 2, 3, 4, 5. It looks like an almost complete circle. The only missing link would be 5 to 1. So then what we could do is we could add a pointer that connects 5 to 1, like this. And now we have a completed circle. And then we need to rotate by 2. So what we're literally going to do is rotate by 2. Instead of thinking about like trying to move the last node to the front and so on and so forth, we're just going to think about it geometrically, like actually turning a circle by 2 points. So rotating by 2 means we're going to go like 1 this way and then 1 this way. So now we want this pointer, which is 4, to be the start of our new linked list, the head of our new linked list. It's going to wrap all the way around here, and then we have to get rid of this pointer right here. So then 3 becomes the tail of our new linked list. So now, since we know that our linked list has a length of 5, we want to move forward 5 minus 2, or 3 nodes from the original head of the linked list, which was 1. So we go 1, check, 2, check, 3, check. And this is going to be the tail of our new linked list. So now we want to remove the pointer that connects 3 to 4. So we're going to erase this. And that's that. That's our rotated list. So now, like imagine we straighten this out again. It would look exactly the same as it did before. We have our original 3 nodes in the same place that they were before, these 3 nodes right here. And then we have the last two nodes, which were originally at the end of the linked list, but now got moved to the start of the linked list. Okay, so how do the linear solution and circular solution compare when it comes to time and space complexity? Well, it turns out they're actually very, very comparable. The linear solution is going to take O of n time, where n is the length of the linked list in terms of the number of nodes. And the circular solution is exactly the same. We essentially have to do one pass to count the entire length of the list, and then another pass to actually move the nodes that we want to move, or for the circular case, move the pointers we want to move. And the space complexity is going to be constant. This isn't precisely true for the linear solution that I explained in the beginning of the video, but it is actually possible to do it in a constant space fashion, but it's even more complicated than the way I described. So if these two solutions have the same time complexity and potentially the same space complexity, is there a difference between them? And the answer is definitely yes. You definitely would want to go for a circular solution instead of the linear solution in the context of an interview or even in production code. And the reason why is because the linear solution is just so much easier to screw up. There is so many more edge cases, so much more to think about when you're coding it, whereas a circular solution is so much simpler. You just want to add one pointer and then remove another pointer in two very particular spots. The linear solution, you have to think about a lot more. The code is going to be significantly longer, and there is a much bigger possibility that you make a small mistake, especially in like a time pressured interview. And you just don't want to run those risks and have that unnecessary stress in an interview. So always think about potentially looking at a question in a different way that maybe won't necessarily make the solution more efficient, but can make it easier for you to code it up in a timely manner. If you're finding these videos helpful, I think you'll love what we got going on in our private community. We dive even deeper with exclusive content that won't be shared on the main YouTube channel. I also offer individualized coding interview study plans that are tailored just for you. You can also join small group sessions, participate in mock interviews, and get your questions answered in live weekly Q&As. It's a great way to take your coding interview prep to the next level. If you're interested, check the link in the description below. I'll see you inside. All right, so here is the Python code to solve Leetcode question 61, which is rotate list. So first we are given our linked list here, and I have a small if statement just to check whether the head exists, and if it doesn't, we can just return none because there's no nodes to rotate. Assuming that we do actually have a linked list with real nodes in it, I'm going to start a current pointer at the head of the linked list and initialize tail to none. And I'm going to create this while loop, which is essentially going to count the number of nodes that are found in the linked list. Once we get to the end of the linked list, we now know the length of the linked list, and we also can find the tail because that's the last node we've seen. Next, we are going to make the linked list into a circle like I described earlier. So this means connecting the tail node to the head node at the start. So this makes one large cycle that contains all the nodes in the list. I'm now going to go back to the head node, and we are going to go forward this many times. Length minus k% length, which is k mod length, minus 1. And this is going to offset our start of the node, start of the linked list until we get to the appropriate node that needs to start our rotated list. And once we get there, we are going to establish this as the new head of the linked list because this is the value we're going to need to return. And we are going to remove the pointer that connects this node to the next node in the list. So then the next node that would have been the neighbor in the original cycle is now the tail of our new rotated list. And now all we have to do is return the new head. So now let's run the code, passes all the test cases, and we can click submit, and it does well. So this is the optimal solution.